Hello everyone, hope you all are doing well. So today we will start with the chapter Quadratic Equation. Now when we talk about this chapter, this is the most basic and the most initial chapter of JEE mains. And again, more or less each and everything that is covered in this chapter have already been done by you in your class 10th, 11th and 12th. So there isn't anything new that you are going to be studying in this chapter apart from a few graphical concepts. Apart from this, you are going to see that in this chapter, each and every concept you are going to be revising and not learning. So without further ado, let's start. First, we will be looking at a brief of what polynomials are, their remainder theorem, their factor theorems. After that, we'll look into what quadratic equation are. From polynomials, we will start deriving what our quadratic equations are. And then we will look into the roots and coefficients, nature of roots, equations, how we can convert our equations into quadratic equations. Then we will look at a few common roots, graphical representation and location of roots. Again, a few more topics. All these topics I very well know you all have covered during your class 10th. Apart from graphical representation, you all know a very good brief about this chapter. So it isn't going to be a very new topic for you to learn. So without further ado, let's start. So talking about polynomials. What is a polynomial? A polynomial is an algebraic expression where the exponents of variables are non-negative integers. So basically what we are saying is, I can consider any equation f of x to be a polynomial if it has powers of x as whole numbers. So one thing that you must remember, that powers of x must be whole numbers. If they are not whole numbers, then you cannot say that it is a polynomial. Generally, they are in this format: an, where an minus 1 up till a0, these are all simply constants. So x to the power n plus x to the power n minus 1, and this goes up till x, and in the end we have x to the power 0. Again, x to the power 0 is 1, so we do not write it down generally. So this is what a polynomial looks like. Now, if I was to tell you a few more details about polynomials, first of all, you know that the power of x, which is used in a polynomial, it is supposed to be a whole number. The second thing is that the highest power of x in a polynomial is known as the degree or order of that polynomial. So I'll write it down for you. The highest power is called as the degree, is called the degree of that equation. Degree, or it is also known as the order of that equation. Order of that equation, or we can call it as the function or the polynomial. So this is an important thing that you must remember. So now if I was to tell you an example, let's say if I have 1 by x, would you say that this is a polynomial? No, because if you convert this into, let's say, the numerator form, what would it become? It would become x to the power minus 1. And is minus 1 an whole number? No. That means it is not a polynomial. Taking one more example, let's say if you have root x, if you convert it into power form, what would it become? X to the power 1 by 2. And is this a whole number? Not a whole number. Sorry, not a whole number. So again, this wouldn't be a polynomial. So you must remember this thing and check whether which of these are polynomials or not. So the first and foremost thing is for you to check if all powers of x mentioned in the entire equation is whole number or not. So let's say if you have let's say if you have x cube plus x square plus x plus 1 by x, would you say this is a polynomial? No, because at one of the places the power of x is not a whole number. That means it is not considered a polynomial. Polynomials can only be considered if all powers of x are whole numbers. Now, how do we convert our polynomial into a quadratic equation? If we take our highest power, if we take our degree to be 2, which is the highest power, then it becomes a quadratic equation. quadratic equation. And how do we represent our quadratic equation? So it would be represented as a2x square plus a1x plus a0. This is the way how we can represent our quadratic equation. So this is how we generally represent a quadratic equation. This is what it looks like. Now, since writing a2, a1, a0, this becomes a little bit hectic for us. So what do? Is we simply represent our quadratic equation in this format. Ax square plus bx plus c, where we consider our a, b, c to be constants, and this is our quadratic equation with the highest degree being 2. Now let's say if my highest degree is 3, then it wouldn't be a quadratic equation. It would be transformed into a cubic equation. If my highest degree is, let's say, 4, then it would be transformed into a biquadratic equation. So keep these things in mind. Now talking about remainder, let's say you have been given a long polynomial and they have given you a divisor as well. Then what would be the remainder of solving that entire function? Simply what we do is, if a polynomial px is divided by x minus a, let's say this is my polynomial px and I divided by x minus a. So here I would have my quotient, this would be my quotient, and upon solving this entire division, here I would have my remainder. So how do we find out the remainder? The remainder can directly be found out by putting the value of a in the equation. So p of a would become my remainder. So if I was to show this to you with the help of an example, you can see here, find the remainder when px is this. They've given us a polynomial and this polynomial is divided by x minus 2. That means I have to divide this entire polynomial by x minus 2. So what would be my remainder? Simply what am I going to do? I'm going to put my px as p2 and find out what would be my remainder. So this would be 2 cube minus 2 times of 2 square plus 6 into 2 minus 5. So from here what do we get? 8 3s are 24 minus 4 2s are 8 plus 12 minus 5. So from here we get 13 minus 1, so we get 23. This is my answer. This is my remainder basically. So this is how generally remainders of any function is found out. Now let's say if they had asked you to find out the quotient for this, then it becomes a very hectic task for you. You have to divide it entirely. Again, this division you've already learnt before in your earlier classes. X minus 2. What you do is you multiply it by 3x square, because so that you can cancel the first term off. If you multiply this entire divisor by 3x square, you are going to get 3x cube minus 3 2s are 6 x square. From here what do? Is we subtract these two terms. So this would simply get cancelled out, and since we are subtracting these two terms, my minus 6x square would become plus 6x square. So here we would have 4x square, and I take the second term down as well. Now upon taking the second term down, now this is the equation that is left with me. Here I can take minus 5 as well down. Now what if I multiply this by plus 4x? Again I can cancel out my first term. So this would become 4x square minus 8x. And from here again, after subtracting, this would simply get cancelled out. And if I subtract this, minus 8 would become plus 8. And from here we would have 14x minus 5. Now if I use x, simply what I can write here as, this would become plus 14. So here I would get 14x, and here I would have minus, this would become 28. And again if I subtract this entire term, minus 14 would cancel out, minus 28 would become plus 28, plus 28 minus 5 gives us 23. So this is one way of finding the remainder. Either you do the entire division and then find out your remainder, or you can simply directly substitute your a value into the equation and find out your remainder. Now let's say if when I substitute my a value in my function or my polynomial, and if the remainder comes out to be 0, that means what do we say? It is a factor. I hope you all know this. Again, repeating these things that you have already studied. So factor theorem again is nothing. When we get pa is equals to 0, we say x minus a is a factor of this polynomial. Now we've been given a polynomial x square minus 3x plus 2. Use factor theorem to factorize this polynomial. So what are the values of x at which I would get this equation to be 0? So I say x square minus 3x plus 2. What are the values of x at which I can get this equation to be 0? Let's say if I factorize this, I would simply get x minus 2, x minus 1. Again, you can use all that formulas of quadratic equation to find out your factors. Again, those are not necessary. You can directly see that minus 2 minus 1 would make it minus 3 and 2 into 1 would make it 2. So directly you can write down the factors. So from here, you can say that either x is equals to 2 or x is equals to 1. Either of these two terms, if my x is 2, I would get my equation to be 0. If my x is 1, again I would get my equation to be 0. So I can say these two are my factors. So my factors for this equation basically becomes x minus 2 and x minus 1. So this is generally how you use factor theorem. Now what happens in quadratic equation is, let's say you found out two factors, which is 2 and 1. Now what you can say is that whenever I will put 2 in this equation, if I put 2 in this equation, my answer would come out to be 0, right? So that means I call this as a root. I also call this as roots. Factors of any quadratic equation are known as its roots as well. So 2 is one of my roots and 1 is one of my roots, because if I put these values in my equation would come out to be 0. That means it is satisfying the equation. That is what I mean to say. Now again, talking about quadratic equation, it is a second degree polynomial with a single variable x. The general form is represented as ax square plus bx plus c. A, b, c are constants. A shouldn't be equal to 0. B and c can be 0. If a becomes 0, that means this entire term would be struck off. Then I would have a linear equation. This wouldn't be a quadratic equation anymore, right? So for it to be quadratic equation, a shouldn't be equal to 0. Now solution. This thing you must have studied in your class 9th. So if you have a quadratic equation, ax square plus bx plus c is equals to 0. If let's say I'm not being able to directly find out my factors or roots of this equation, so how can I find out? I can simply write down x is equals to minus b plus minus. Of course, there are going to be two roots. That is why we write plus minus. Root under b square minus 4ac upon 2a. This is how we find out my factors. So whatever the value, two values of x that I'm going to get from here, those two would become my roots. And x minus that root would simply become my factor. So this is how you write down the solution. Now when we talk about this entire solution, what do we have inside the root? B square minus 4ac. We call this b square minus 4ac as the discriminant. So my discriminant is b square minus 4ac. Now let's say if my discriminant, which is inside the root, if it is greater than 0. If it is greater than 0, that means inside the root I would have a real value, positive real value. And if it is a positive real value, that means it would open up into some square root of it, right? That means I can have two real solutions, which are going to be real and distinct. So keep this thing in mind. Discriminant, this d, is also represented by delta. So if delta is greater than 0, my equation would have two real and distinct roots. If it becomes equals to 0, that means inside my root under, what am I having? I'm having a 0 inside it. That means my equation would transform into x is equals to minus b plus minus 0 upon 2a. However, if I add or subtract 0, it remains the same. That means I'm going to have just one solution. So generally what we say is I'm going to have one solution. However, it is two real and equal roots. That is what we say. We are considering it to be two solutions. However, they are equal solutions. So keep this thing in mind. And when delta is less than 0, let's say if inside the root I have minus 24. How can we find out the root of minus 24? It is not possible for us. So it is an imaginary number. That is why we say the equation has two complex roots. So remember this thing about the discriminant. Comes handy while solving questions. Now, taking you deep into the talk of roots and coefficients. Generally, whenever I say I have my equation as ax square plus bx plus c is equals to 0. This is my quadratic equation. I assume initially that my roots, the values that are going to satisfy this equation are two, which are alpha and beta. And if these two are my roots, that means these two would satisfy this equation. That means I can say a alpha square plus b alpha plus c would be equal to 0. For beta also, a beta square plus b beta plus c, this would also be 0. So these two equations would be satisfied if alpha and beta are my roots of equation. Now, how can we find out the relation between these two roots? If I was to relate these two roots in terms of a, b and c, how can I write it down? My sum of roots, alpha and beta, would be written down as minus b by a. So my alpha plus beta is basically minus b by a. And my product of roots, alpha beta, my alpha into beta, this is c by a. And difference between the roots, alpha minus beta. Now this is under modulus, and I hope you all know what is the function of modulus. Modulus makes anything which is inside it, either it is negative or positive, the answer would come out to be positive. It makes the value positive. So that is why we do not know whether our alpha would be greater or our beta would be greater. That is why we say alpha minus beta modulus. This is equals to root under discriminant divided by modulus a. So alpha minus beta mod, this is equals to root d by modulus a. Again, modulus a is, why are we writing it down as modulus a? So that we get our answer as positive. If a is negative, then the value outside would become positive, negative, right? And if it is negative, then it cannot be equal to a modulus value. That means what am I saying is modulus x can never be equal to a negative value. That is why I'm writing it as modulus a. So again, remember these things so that it becomes easier for you to solve for the roots and product of roots. Now let us look at this question about products of roots so that it becomes fairly clear to you. If the product of the roots of the equation has been given, is 7. That means, what have they given us? Let's say if this is my equation, 3kx plus 2 e to the power 2 log k minus 1, this is equals to 0. Let's say if I have two roots, alpha and beta. If these two are my roots, what can I say? My alpha plus beta would be minus b by a, And what is my minus b here? My b value is basically minus 3k, right? In this equation, let me write it down here properly. My b value is minus 3k. What is my a here? A is 1. And what is my c here? C is 2 e to the power 2 log k. This log is basically has the base e here. So keep this thing in mind. This is ln k, or let me write it down in that format only. This is ln k minus 1. So these are my values. So what would my alpha plus beta become? Minus b. So this would become 3k by a is 1. And my product of roots, alpha beta, would become c by a. So what is my c? 2 e to the power 2 ln k minus 1. Again, my a is 1, so I am avoiding writing down the 1 in the denominator because it doesn't matter. Now what have they told to us in the question? That the product of these roots is 7. So that means this value is equals to 7. Now I have to find out the roots are real for what values of k. So from here, what is the value of k that I'm going to get? If I solve this equation, this would become 2 e to the power 2 ln k is equals to 8. This would become e to the power 2 ln k is equals to 4. And how can I write this e to the power 2 ln k? This can be written as e to the power, ln of k square. Because inside the logarithmic value, whatever powers I have, I can take it outside as multiplication, right? So I can take it reversal as well. So that is what I've done. This is equals to 4. And now I hope you all know for powers, we can simply substitute the powers if we have e and ln. So this would become k square to the power ln e, and ln e is nothing but 1. So simply I can remove this portion. So k square becomes equals to 4. If k square is equals to 4, that means what can I say? This is equals to root 4. And what is root 4? Root 4 is plus minus 2. We do not know either it is plus 2 or minus 2. That means we have gotten two values of k here. Now what would be the value of k for which we would get our roots to be real? So first of all, let me write down my equation for both the values of k. So for first value of k, what do we get? This would become x square. For plus 2, my equation becomes x square minus 6x plus, and here what are we going to have if k is 2? So this would become, e can simply be removed from 2 square. This would become 4, 4 2s are 8, minus 1, 7. So from here, this is the equation that I'm getting. And what would be my equation if I take k to be minus 2? It would become x square plus 6x. And inside here, we would have 2e to the power 2 times of log e minus 2. Minus 1 is equals to 0. Now I hope you all remember, while studying logarithms, we had studied that inside the logarithmic, there cannot be a negative value. Whatever is inside ln, it should be greater than 0. So that means directly we can cancel this off. This cannot be our answer. So that means this is our answer. And also you can check it out as well if you are getting the roots to be real. Value of x, if I find out, let's say my discriminant for this. Discriminant would be b square minus 4ac. What would be my discriminant? It would become b square, which is 36, minus 4 times of a into c. A is 1, c is 7, so 7 4s are 28. So this becomes 36 minus 28, which makes it 8. That means my d is coming out to be greater than 0. That means I can have real and distinct roots from here. That means I can take my value of k to be plus 2. Again, here when we look at the value of k, which is minus 2. Now inside the logarithm, I hope you all remember, we cannot have a negative value inside the logarithm. It always needs to be greater than 0. So simply we can reject this portion because this minus 2 cannot be possible. So that is why we get our value of k to be plus 2 for this equation. Now let's say if we have a cubic equation, how are we going to represent our roots for this? You can take this as an example. Let's say if you have a cubic or a biquadratic, or you have a 5-degree equation, a 6-degree equation, simply what are the ways of you writing it? Sum 1, this would become alpha plus beta plus gamma. Since this is a 3-degree equation, that means I would have 3 roots for this equation. Whatever is the degree of that equation, that is the number of roots that I can expect for that equation. If my discriminant is, let's say, greater than 0. If it becomes equal to 0, then I can have less than the degree of roots as well. So for the timing, we assume all are real and are distinct. So alpha, beta, gamma, these 3 are the roots of this equation. So from here, what I can say is my sum would be minus b by a. Now sum of roots taken 2 at a time. Taken 2 at a time, this would be c by a, and product would become minus d by a. So keep this in mind. First it is a negative sign, then it comes with a positive sign, then it is a negative sign again. Now one more thing, that for quadratic, I want to tell you, based on this you would be able to write down your cubic equations or your biquadratic equations or anything. If you have your roots, if you know the sum of roots and you know the product of roots, how can you write down your quadratic equation based on the roots? Now you have the roots. How can you write down your quadratic equation? It can be written as x square minus alpha plus beta x plus alpha beta is equals to 0. So basically x square minus sum x plus product is equals to 0. This is how I can represent my quadratic equation as well. So if you try to replace your sum, what is your sum? Minus b by a. So minus b by a, this would transform into x square plus b by a x. Product is c by a, this would become equal to 0. If you take LCM, we would have ax square plus bx plus c, and if you cross multiply a into 0 would be 0. So you've gotten your quadratic equation. So similarly, in this format, you can write down your cubic equation as well. If you know the roots, you can find out your quadratic equation. Now the same thing for a 4-degree equation, which we also call as the biquadratic equation. Sum 1, sum of all roots taken one at a time. Here we are considering that we have 4 roots. One is alpha, one is beta, one is gamma and one is delta. So you can see the sum of roots taken 2 at a time, sum of roots taken 3 at a time, and then finally the product of roots. These are the values that we get.